Good day, grade 11s, and welcome to the very first video of the grade 11 Geomorphology series. Yes, I've created a new playlist, so this will be the first video of many videos to come. And so let's please subscribe, let's like, let's comment, let's share, so that this channel can grow bigger and bigger, and so that we can get encouraged to upload more videos for you guys. As you can see from the presentation in today's video, we will be covering the topography associated with horizontally layered rocks. So we will break down all of those, guys, every single landscape that you have to understand and fully know about, all the characteristics and all the processes that are associated with each and every one of them. Now, from our CAPS document, this is the very first subtopic, topography associated with horizontally layered rocks. So today's video will be covering this very first part, which is the characteristics and processes associated with the development of these horizontally layered rocks. And that includes your hilly landscapes, basaltic plateaus, canyon landscapes, and Karoo landscapes. We'll be looking at every single landform that you have to know and how they form. Very important, the formation, as well as the impact these have on human activities. So we'll also cover that. And we'll also take a look at the concept of scarp retreat or back wasting, and as well as the utilization of these landscapes by people. So we'll cover everything here, guys. And so this means that in our next video, we'll be looking at topography associated with inclined or tilted rock strata. Right, so I don't want to waste any more time, guys. Let's just get into it. Right, in order to first understand these, you have to first understand how rocks form. And I know that you must have covered this in grade 10, the different types of rocks. And so I thought that it would be quite instrumental that we start there, looking at the different types of rocks. Basically a reminder how different types of rocks form. I think this will help a lot in understanding the different types of landscapes. As you know, from grade 10, we discussed the different types of rocks. You have three types of rocks. You have your igneous rocks, you have your sedimentary rocks, as well as your metamorphic rocks. And how they form is quite important in understanding how these landforms develop and all the processes that are involved there. So taking a look at the igneous rock, igneous rocks are rocks that form from the cooling and solidification of molten rock. So guys, as you already know, beneath the Earth's surface, as you go down deep towards the inner core, it gets hotter and hotter. So the pressure increases, the temperature increases. And so you can imagine rocks that are thousands and thousands of kilometers below the Earth's surface must be molten. So you have molten rock beneath the Earth's surface, right? Now this molten rock beneath the Earth's surface, due to these high temperatures and pressure, is named differently depending on where it is. So if it is below the Earth's surface, this molten rock, then we will call it magma. So you have magma, we call that magma. Okay, I should maybe sort of draw a magma chamber. So that is magma. This is molten rock, but beneath the Earth's surface. Right, so if it is beneath the Earth's surface, we call that magma. But now this magma can actually reach the surface. Due to pressure differences and many other processes, this magma does make its way on the Earth's surface, right? So it goes up and up and up, and it makes its way onto the Earth's surface through cracks and through joints. And so now you have this molten rock, but it's on the Earth's surface, right? Now we then call that lava. Okay, this molten rock, if it is on the Earth's surface, we call it lava. If it is beneath the Earth's surface, we call it magma. Okay, it's still molten rock, guys. But now when it solidifies, when it cools down and solidify and become a rock, like solid, we then say that it is an igneous rock. Okay, so it's as simple as that. So you have igneous rocks that were formed from the cooling and solidification of magma. Okay, so meaning which they cooled below the Earth's surface. Okay, and those igneous rocks, we call them intrusive igneous rocks or plutonic igneous rocks. So a perfect example would be your granite. These are simply your rocks that cool down below the Earth's surface. They were not able to make it to the Earth's surface, and so they cooled down and solidified below the Earth's surface. So those are your intrusive rocks, and we'll talk about the different types of landforms you get underneath the surface, because we have names. We have dikes, we have sills, we have batholiths, laccoliths, so on and so on. Those are different types of intrusive rock landforms. Okay, so we say that these are intrusive rocks. They formed from magma that cooled down below the Earth's surface. Okay, those are your intrusive rocks. Intrusive, inside or beneath the Earth's surface. So magma slowly cools beneath the Earth's surface to form rocks. And this is quite a slow process because the temperatures are still quite high. They are not exposed to the surface, whereby the temperatures are really low compared to the temperatures that are beneath the Earth's surface. And so they take their time when cooling, and hence they form big crystals that are visible. Okay, so when I'm talking about crystals, guys, I'm talking about the minerals that form rocks. So these, for an example, so these are your different types of minerals that you get that form a particular rock, your feldspar, your quartz, so on and so on. These crystals are big because the magma cooled down very slowly. They had enough time to form those big crystals. You also have igneous rocks, as I said, that form from the lava now, lava solidifying, right? So you have that magma making its way onto the Earth's surface, and it gets exposed to the very low temperatures here, and so it cools down very rapidly. And those crystals will not be big. They're going to be quite small or not even visible, actually, because it has cooled down rapidly, and so they were not able to form those big crystals. So we call these extrusive rocks or volcanic rocks. These are simply rocks that have formed from lava cooling rapidly on top of the Earth's surface. That magma has now made its way onto the Earth's surface, and now we call it lava. And this lava has now cooled very fast to form these extrusive rocks. Okay, we call them volcanic rocks. And a perfect example is basalt. Okay, so basalt, this is an extrusive rock, and we'll actually talk about basalt. Basalt forms from lava cooling rapidly on top of the Earth's surface. Right, so that's your two types of igneous rocks, your intrusive rocks and your extrusive rocks. Now let's move on then to the sedimentary rocks. Now sedimentary rocks, these are rocks that form from the accumulation and compaction of sediments, sedimentary sediments. So sediments are simply like your pieces of the other rocks, your minerals. It's basically bits and pieces of other rocks that have eroded. Okay, we know the process of erosion, guys. Erosion, that's simply the removal of material. So if you have, for an example, let's say this is igneous rocks. So igneous rocks, they erode. This means that bits and pieces of this rock, okay, will be eaten away, okay, by wind, by water, by chemical processes, so on and so on. So this rock will be broken down, it will form cracks. Okay, we call that weathering, the breaking down of a rock. So it weathers first, and then these bits and pieces of these rocks are then eroded, so removed. That is erosion, guys. Removal of material from rock. So now these bits and pieces of rocks now will form a layer there. Okay, bits and pieces of that rock as well. It is eaten up. It is weathered first, and then it is eroded. And so these sediments will form a layer of sediments, as you can see. And so now you have formed that very first layer, and then more and more sediments are deposited on top of these, on top of this layer of sediments. Now, you're going to start to see that you have more and more sediments that are deposited on top of each layer and each layer and each layer. And so this is that accumulation, okay, accumulation of sediments. And then now each layer presses on top of the other layer such that there will be compacted. So there's no longer going to be any of that space in between. So they will be very much compacted and solidify. Each new layer presses on top of the previous layer, and more of these sediments get closer and closer together, and so they become compact, right, and solidify and become a rock. So due to this high pressing, this layer will form a sedimentary rock at some point, but it takes a lot of time, millions and millions of years. And the easiest way to spot sedimentary rocks is that they often have visible layers. Okay, they have these layers of sediment, as you can see, guys. This is the very first layer, and that is the second layer, so on and so on and so on, and more layers join. And now those sediments become compact and they solidify to form a sedimentary rock. Okay, so here's an example here, guys, of a sedimentary rocks. There we go. So you can clearly see here the stark difference between these two. You can tell that, okay, this is an intrusive igneous rock because of these big sized crystals. And you can also tell that this is a sedimentary rock over there because, of course, you can see those layers. You can clearly see those layers. Those layers, we call them strata, guys, right? So a rock layer, we call that strata. Okay, so that is one rock layer, for an example, from here to there. That is one strata, and you can see another strata from maybe there to there, so on and so on. So these are strata, these are rock layers. Strata, rock layer, same word. And we also call these the lines that divide them, we call them bedding planes. So the line that is between this layer and this layer, okay, or between this strata and that strata, this line over here, okay, we call that the bedding plane. Right. So you can clearly tell that this is a sedimentary rock. So sedimentary rocks are also useful a lot because they contain fossils. They are able to conserve your fossils because these do not eventually melt and become magma and hence destroy the fossils that are within them. And then the third type of rock that we have is the metamorphic rock or metamorphic rocks. Metamorphic rocks are simply rocks that have been changed from their original form. Maybe it was an igneous rock at some point, it was a sedimentary rock at some point, but it has now been changed due to the intense heat and pressure deep within the earth. So if, for an example, I have a rock, maybe over here, it's a rock, and then this rock is then exposed to high temperatures. Maybe this was an igneous rock. It has already solidified, and due to many processes, it has now been exposed to very high temperatures, very high pressures below the Earth's surface. This will then change the composition of the rock, like the minerals, the structure of the minerals. They will change, they will be altered because of this exposure to high pressures and high temperatures. Okay, so it now is no longer the same. It's no longer that igneous rock that looked, that had that particular appearance. It is different because of this exposure to high temperatures and pressures. Okay, so those are the three different types of rocks. But I will make a reference to the first two, the igneous rocks and sedimentary rocks, in order to ensure that you understand these different types of landscapes. So we start off with the first one, guys. But before we do that, let's first start off with some new terms. So the subtopic says topography associated with horizontally layered rocks. So topography actually means the shape of the land. How is the land shaped? How does it look like? So that is simply topography. Horizontally layered rocks. So we're specifically looking at rocks that are horizontally layered. So that is the type of topography we are looking at here. Okay, if they ask you what is the topography of this particular landscape, you then will say horizontally layered rocks. It's a type of topography. So horizontally layered rocks, these are the flat layers of rock material that are formed on top of each other, and we call them strata, guys. Okay, we said that they are strata, these layers. So we start off with the first landscape, which is the hilly landscapes. Now, hilly landscapes are simply areas that consist of many hills that are undulating. Okay, so undulating simply means smoothly rising and falling. Okay, like wave-like. Okay, it's like a wave. Go up, you go down, you go up, you go down, you go up, you go down. They are round. It's made up of these hills, as you can clearly see here, guys. I got this from ChatGPT. So this hill is going down, and then it goes up, and then it goes down, so on and so on. So that's what characterizes hilly landscapes. They are made up of these hills. Hills, guys, are simply rounded natural landforms that rise and fall compared to the surroundings. They are quite smaller, they are quite smoother, and they are quite shorter than a mountain. So if, for an example, you compare this image over there compared to this landform is quite smoother, it's quite gentler, it's quite shorter than that one. This one, we can say it's rugged, it's rough, and it's quite high. It's a high-lying landform. So these are your hills. So if an area is made up of these many hills that are undulating, we then call it a hilly landscape. So the term quite explains everything. And if I zoom in here, you're actually going to find out that these hills are made up of layers, horizontally layered rocks, as we said, or landforms. So this means that this, at some point, okay, this was flat land like that. Okay, it had these layers like that, but due to erosion, due to weathering, and due to the nature of these rocks, in terms of resistance, they have a weaker resistance to erosion, and so they get eroded quite simply. And so now you have these spaces opening up, and hence you have removed all of this material over here and over there, and now it has formed these hilly landscapes, this undulating form or structure that you see there. As I said, these are your strata, okay, the different types of layers, and then the boundary between them, right? And the boundary between that strata and the following strata beneath it, that boundary there, we call it a bedding plane. Okay, so those are your hilly landscapes, guys. It's quite easy to identify them. They are characterized by many hills. They have this quite gentle gradient, and they are quite shorter. So we call that a hilly landscape, and going down and up and down and up like a wave, down and up and down and up. So that's what we mean by that word, undulating. So these hills that are undulating, that is your hilly landscape. Now a hilly landscape is rich, okay, it's lush in vegetation, particularly hilly landscapes that form in humid areas that receive a lot of rainfall. And so you get this vegetation that grows. And so due to the presence of water, the availability of water, you have grass forming, different types of plants that form there. So we say that it is rich in vegetation, particularly hilly landscapes that are found in humid areas. So climate does have a huge impact on how your hilly landscape will look like, as I will illustrate. And then high rainfall results in sheet erosion, creating these rounded hills. So sheet erosion is simply the removal of one thin layer. And so you can sort of imagine sheet erosion is simply a removal of a thin layer, or one layer, so one layer at a time. So you can sort of imagine maybe removing this part, okay, removing that particular part at one go, okay, or a thinner part. So all of that is removed at the same time, and so they get shorter and they get more rounder. They develop that gentle gradient. And as I said, the shape of these hills is largely influenced by the climate of the area. And high temperatures promote chemical weathering. So supposed to be chemical weathering. Chemical weathering is simply the breaking down of rocks due to high temperatures. Okay, so if you expose rocks to high temperatures, you're going to have mineral composition changing. You're going to see these types of shapes like this one. Okay, look at this. These are hills, but now they have these gullies, okay, these areas of erosion. As you can see, large narrow areas of erosion, as you can see over there. So we call those gullies, right? And again, a gully, guys, it's a long narrow area of erosion, call that a gully. Now I will cover that in a moment. Let's start here. Okay, when you have warm, high rainfall climate, these are the types of hills that you produce. Okay, because there's enough water, it is humid, that is conducive. That is a conducive environment for the grass, for the different types of plants to grow. So due to high rainfall, sheet erosion occurs here, and it results in these rounded hills that we see. The presence of vegetation due to the wet climate here promotes infiltration and prevents excessive erosion. So if you have a lot of vegetation due to the climate, when it rains, if it happens that it rains, that rain will be infiltrated, okay, or it can wash off down the hill like that. So that sheet erosion I talked about, remove some of the material there down the slope. But most importantly, guys, you have vegetation. And so if you have vegetation, vegetation prevents erosion or prevents a lot of surface runoff. You're going to find out that more water is absorbed than running down the slope as surface runoff. So vegetation promotes infiltration. Infiltration, that is the absorption of water through the surface. And so this is the type of hilly landscape that we see here, rich in vegetation, rounded. It does not have any gullies. We see sheet erosion. It prevents a lot of erosion, excessive erosion. And yes, we do not see chemical weathering, a lot of chemical weathering here. But if you expose these hills to hot, low rainfall climate, and then this is what you see. So due to the dry climate, we observe sparse vegetation here. There's no vegetation at all, or there's very little amount of vegetation due to that dry climate, which exposes the rocks to these extreme weather conditions, because vegetation sort of serves as a cover and basically prevents the rocks, or covers the rocks from, or the soil from that high temperature or extreme temperature or extreme weather conditions, like your high wind speeds, your floods, your high temperatures. And so this speeds up the weathering as well as the erosion process, forming a rugged landscape with sharp edges, steep slopes, and colorful layered formations. As you can see, the colors here, that's due to a lot of exposure to high temperatures, and so that also changes the mineral composition a bit as well. And so that's what we see. We see rough landscapes with a lot of erosion, and that's why we see these gullies there. And this area, we call it the Badlands. So Badlands is simply that hilly landscape, but now it has a lot of bizarre landforms. You have a lot of gullies because these hills are exposed to extreme temperatures. So it's important, guys, that we note how the climate of the area influences the shape of the slopes here in hilly landscapes. So it's really, really important that you are able to differentiate which one of these two areas has a warm, high rainfall climate, or which one has a hot, low rainfall climate, and you are able to reason, as I've mentioned there. Now, what impact do these hilly landscapes have on human activities? Well, particularly this one right over here, it produces fertile soil for farming, and so you can practice farming here, implementing a particular farming technique, like your contour plowing. And this is quite a conducive climate, so it's really good for farming. It has a warm weather, high rainfall, so you can practice farming here. Right, so those are your hilly landscapes, guys. This is simply an area that consists of many hills that are undulating, like as I said, guys, rising and falling and rising and falling, and their characteristics and the type of climate, as I mentioned, really influences. It has a huge influence on the type of hilly landscape that you're going to form, like the individual hills, how they look like. And so that's quite important that you are able to discuss how the climate of an area influences the shape of slopes in hilly landscapes. All right. So now we're going to move then. We're moving now to the second type of landform, and we call that the basaltic plateau. Basaltic plateau is important that you're able to explain how it forms, right? It can have a 4 marks question in your exam or in your test, where they ask you, how does a basaltic plateau form, right? So you have to be able to really explain that well, and its definition actually has part of its formation in it, right? Remember basalt, guys, we talked about that. We said it's an example of a what? Of an extrusive rock. An extrusive rock, or extrusive igneous rock, or volcanic rock. Where we said an extrusive rock is simply a rock or an igneous rock that forms from lava cooling down rapidly on top of the Earth's surface. So therefore, basaltic plateau should form from lava cooling down. So a plateau is simply like a high-lying area with a flat top. So that is a plateau. Now basalt is the type of rock. So this is the type of rock, that means it's extrusive, and this is the type of landform, like the shape of the landform. So extrusive, so basalt is a type of rock, and then plateau basically describes the shape or the topography. How does it look like? Well, it's a high-lying landform or area with a flat top. Basaltic plateaus form from layers of lava that flow horizontally onto the Earth's surface. Okay, layers, not one layer, multiple layers of lava that flow horizontally onto the Earth's surface. So that is exactly how they form, guys. They form from layers of lava. First, you have to have a crack, or these, we call them fissures. Okay, those are simply cracks. So if you have cracks on the Earth's surface, then you're going to have magma making its way through those cracks and flooding, basically. We also call these flood basalts. They will flood and form this particular layer. So they're going to form the first layer like that. Okay. And more and more and more and more and more eruptions will form another layer over there, and form another layer over there, and form another layer over there, and immediately solidify. And so they form these basaltic plateaus over time after solidifying. So this is how they form successive fissure eruptions. Okay, successive, that means one after the next, after the next, after the next. So successive, multiple fissure eruptions, that means the magma making its way onto the Earth's surface, it erupts. Okay, that's what we call that. These eruptions cause thick, smooth, fluid basalt to flow horizontally. Horizontally, guys, this is important. You have to mention that they flow horizontally. They love to ask those questions. If you look at the past papers, you're going to have those columns where you're supposed to match. And even in questions, they usually like to ask, do basaltic plateaus form from lava that flows horizontally or vertically? So it's horizontally, guys. It flows horizontally, that basalt, right? That lava over there. So it flows horizontally onto the Earth's surface. That's the first thing that occurs. Now, each fissure eruption results in a basaltic layer, right, accumulating on top of the previous one. Each one, so this means that this is the first one. So after you have formed this first one, you had another fissure eruption that led to the second one being laid on top of the first one. So that's how it goes, guys. And another fissure eruption will result in another layer. If I have another one, this other fissure eruption will result in another layer forming there on top. And so that's how basaltic plateaus form. These layers give rise to a basaltic plateau. And sometimes you're going to find out that a slope has a basaltic top, where this is basalt, right, having those layers, and then beneath it, maybe it's a different type of rock, or it can be basalt, like the whole basalt as a whole, like that. Okay, a perfect example is, for an example, the Deccan Plateau in India. That's an example of a basaltic plateau that was formed from lava flowing horizontally, each eruption forming a new layer that accumulates on top of the previous one, so on and so on and so on. Okay, so we call that a basaltic plateau. Characteristics of basaltic plateaus is that they have the same height, and having the same height, guys, we mean that it has a flat top like that, as you can see. Okay, it's flat topped. Each part of this is quite flat, topped like that. So this means that this basaltic plateau has uniform resistance to erosion. Having uniform resistance to erosion basically means each part erodes at the same speed, at the same rate. So if let's say this is A and that is B, if A and B have unequal resistance to erosion, maybe let's say A has a lower resistance to erosion, then it's going to erode quite quickly. This side will erode more. Okay, more of this material on A will be removed because it is a softer rock. So now it will look something like that. Okay, this is for unequal resistance to erosion. But a basaltic plateau has the same height like that. Okay, it's the same height. So that suggests that each part erodes at the same rate. If these erode, they erode at the same rate. That's what we mean there. Materials are removed at the same speed everywhere over there. And so that's why it preserves the height. So it's the same height due to this uniform resistance to erosion. So that is one important characteristic of basaltic plateau. They are going to have that flat top. So that suggests that each part erodes at the same speed. So that's what we mean by uniform resistance to erosion. It has rugged slopes. So this indicates that the rock type that forms the slopes is not maybe uniform to erosion. So it really depends. If these, for an example, like these, the slopes, okay, so the sides like that, they are not the same. And they are going to have maybe, let's say, those ravines or those areas of erosion there like that. And so this means that maybe the rock type beneath this is not uniformly resistant to erosion. Okay, so rugged, guys, we mean it's not straight, like rugged, it's something like that. So that means that each part, maybe this part is not resistant to erosion, that part is more resistant, this part is not resistant, so on and so on. So that's what we mean by these rugged slopes. But as I said, it depends also on the type of question. I'm just preparing you guys for any possibility. And the weathering of basalt produces soil that is fertile for farming. Okay, so basalt weathers, so it breaks down, it has cracks, breaks down, so that is weathering, and then it is then eroded like that. So these bits and pieces of these rocks will form soil. Soil forms from rock. You first have rock, and then that rock is exposed to erosion and weathering. It breaks down, and its bits and pieces will form soil. They produce soil. Now, let's take a look at the impact that basaltic plateaus have on human activities. So, the positive impacts is that the physical shape or the aesthetic appeal, the beauty of the plateau makes it a tourist attraction. So, it's good for the economy. You have tourists that are going to come from other countries to your country to really enjoy the beauty of the plateau. And because they've gone to your country, that means they buy from businesses from your country, they stay at hotels from your country. So that's good for the tourism, that's good for the economy, because that means that businesses will benefit financially. The rugged or rough slopes encourage extreme sports in the area, boosting the economy of the area as well. So you have sports such as your mountain biking, so on and so on. They can be hosted at your particular country. Maybe it's an international sport. If it is hosted at your country, then more people come, and those sports actually bring money into the country. Weathered lava produces fertile soil, producing rich soil for farming. It's very good for farming, as I mentioned, guys. Produces a very rich soil. Then what about the negative impacts? Well, the high altitude of the landform discourages human settlement, as it is dangerous to live in such altitude. So you cannot have a house there. You cannot settle there. That is dangerous, of course. So it's not good for human settlement. Number two, the rough steep slopes are not suitable for farming. Okay, you cannot practice farming on those steep cliffs, as you can see. Yes, we said that basaltic plateaus produce rich soil because they weather first, and those particles, each one of those particles will form soil. Okay, so the soil here, yes, that is good for farming, but not the slopes, not the actual plateau, the soil that it produces. Supplement, right? And the high altitude of the plateau will promote frost, making it difficult for farming. Frost, those are your ice crystals that form, and they actually destroy crops. Now, frost forms because of low temperatures. Okay? If, for an example, the surface, let's say, because it's high altitude, it has a temperature, it's very cold, it has a temperature of -5 degrees Celsius, for an example. So when you have air above, that is, for an example, at 7 degrees Celsius, it will cool down because of its contact with the surface, and its temperature will drop, and it will drop below 0 degrees Celsius and drop to your -5 degrees Celsius, for an example. And so now that air particles then, they condense to form ice crystals. The ice is not really good for the plants. It damages plants. It damages your crops. So this would not be a good idea to practice farming on the high altitude on top of the plateau. So that is the basaltic plateaus, guys. You have to be able to explain its formation. Very important. They love to ask its formation as well as the impact that basaltic plateaus have. Also note that basaltic plateaus are uniformly resistant to erosion, hence they have the same height throughout. Now let's start off with the term canyon. What does canyon mean, right? So a canyon is simply, guys, a large area with deep, steep-sided valleys. So a valley, this is a valley, right? So a canyon has these deep valleys. So as you can see, this is a valley over here. That's a valley, guys, right? And a valley is constantly, particularly in canyon landscapes, running water is important, like the river that is running through the valley. As this river is running through this valley, it erodes this valley floor. It erodes it such that it becomes narrower and narrower and narrower, and it becomes deeper and deeper and deeper. So if you have running water here, this running water is actually eroding the rock such that over time they become deeper and deeper and deeper. It's called that we call that vertical erosion. So the river erodes these valleys vertically, and it's the river that actually formed these canyon landscapes. So it's quite important, the role of a river in canyon landscapes. So it's a large area with deep, steep-sided valleys. So these are quite steep. Look at that. That is so steep. And a narrow valley floor. Okay. The valley floor, that is where you have your river. So it's quite narrow. It is not wide at all. So we call this canyon landscape. Now, canyon landscapes develop in dry areas where there's low rainfall. That is the first characteristic of the canyon landscapes. Canyon landscapes develop where the strata has unequal resistance to erosion, guys. Unequal resistance to erosion. Okay. So the strata themselves, look at this. I need you to look at this. Now you take a look at this shape. Now this means that this is a layer. This is strata that is quite strong, right, in terms of resistance. So it has a higher resistance to erosion compared to this one. Look at this one. This one has formed this gentle shape. So you can differentiate these two. You can even take a look at here, for an example. Look at this. This is strata that has a higher resistance to erosion, and then this one has a lower resistance to erosion. This one over here, because it has formed this sort of gentle shape, whereas this has formed this cliff. So this layer over here is different from this one over here. Okay, this one has a higher resistance to erosion, hence it has formed a cliff face like that, whereas the next one beneath it, this one, it has formed this gentle slope. So that's what we mean by unequal resistance to erosion. So the strata that have high resistance to erosion, they form this cap rock. We say that they are cap rock. So cap rock, that means the strata or the layer is hard. It has a high resistance to erosion. It does not erode easily. It takes quite a while for it to erode. It's hard to erode it. And hence they form these steep cliffs, as you can see over there. And then your softer strata will have a gentle slope over there. So you can clearly see, guys, that there's that shape over there where you have this hard strata, and then you have that sloping softer strata, hard, soft, hard, soft, hard, soft, so on and so on and so on. So these have unequal resistance to erosion. Hence, they produce this sort of shape. This is a hard strata, and this is a gentler strata. Okay, this is a hard strata. That's a gentler strata. So they form these steps. It's like step-like. Okay, hard strata, gentle strata, and then hard strata, and then gentle strata, so on and so on. So it's like steps. So that's how you identify these. Quite easy, guys. It has deep valleys with steep, stepped sides. So that is a canyon landscape. It has these, as I said, it has a resistant top layers that form a protective cap with steep cliffs. So a cliff, guys, is that resistant rock that forms a face. It's a vertical landform like that. So that is, for an example, a cliff. So this is your cliff. It forms that cap rock. It's that cap rock. Remember, these are horizontal layers. In terms of the layers, that's how they look like, one on top of each other. So this should be the oldest. This is the youngest, the one that is at the top. Okay, remember, these are sedimentary rocks. They form from that constant accumulation and compaction of sediments, layer after layer, strata after strata. The layers below the cap are less resistant, and so they erode quicker than the cap. Now, how do these form? How do canyons form? The role of a river here is instrumental, absolutely important. Now, we start off with the ground was level. So at first you have quite a level ground, and then you have a river or running water. Okay. Now, running water finds weak spots or maybe joints or cracks. Okay, maybe there's a crack there, right? And now you have running water. Water is running on top of this. And because there's a crack here, this water is able to get through that crack, okay, and sort of open this wider, right? So it erodes this, it takes advantage of that crack, and now you have something that maybe looks like this, right? And more erosion, more and more erosion, both vertical and lateral erosion. So it will erode this vertically like that, but the river will also erode this crack laterally. So it opens this wider, wider and wider and wider and wider like this. So at some point it forms a valley. So now at some point you have something that looks maybe something like that, erodes vertically. And now this river is flowing within this valley, little valley there, and it will erode downwards again. So now this means that there's continuous erosion. And so now you're going to have something that maybe looks something like that. What is that? That is a canyon. Okay, so on and so on and so on, guys. This continuous erosion is started from that river finding the weak spots, finds those weak spots, it erodes them, and so on and so on. Continuous erosion results eventually, it results in the formation of canyons. So at first, we're saying that the ground is level, so it's a horizontal surface, and then you have running water or a river. It finds these joints and cracks, or you can say it incides these joints. That means it erodes. So it finds these joints and cracks on the hard surface layer and it erodes them vertically, right? And then continuous vertical erosion, removal. Remember, erosion is the removal of material. So continuous vertical and lateral erosion results in the formation of deep valleys, okay, with stepped slopes. As I illustrated, guys, these are the stepped slopes. These are the valleys. So that's a valley. That's a valley over there, and it has these slopes on the sides that are stepped. Hard layer, or the hard layers or hard strata, they form the cliffs, and then the softer layers, they form the gentle slopes. Okay, so the more resistant layers form the vertical cliffs, and the softer layers form the gentle slopes. That's how you explain the formation, guys. River is important in your explanation. The joints and cracks, the erosion, of course, is important. And yeah, also mention that the more resistant layers form vertical cliffs, and the softer ones, they form the gentle slopes. Okay, as you can see there, you have harder layers that form the resistant cap rock or the cliffs, and you have the softer rocks or layers or strata that form the gentle slopes. Okay, so the steps as I illustrated there. The role of a river in the formation of canyon landscapes is critical, guys. The river at some point in the past was on the same level, okay, or altitude as the surroundings, but due to continuous vertical erosion, due to finding that crack and eroding it constantly, it dug, okay, it eroded, okay, digging, erosion, yes, same thing. So it dug, it removed material deeper and deeper, and today it is a deep river. This river at some point, it was at this particular level back then, but because it kept on digging, it kept on removing the material, removing the material, removing the material, now we have a shape that looks like this. So this is how it happens, and a river is so important in canyon landscapes. Yeah, that should be deep river. Now, what impact do canyons have on human activities? Well, first of all, it's difficult to build infrastructure here. You cannot build any railway, you cannot build any road, you cannot build any infrastructure here because there's steep gradients. You cannot even have houses here. How can you settle here? It's dangerous to live here because of this steep gradient. And it's also quite expensive because you have to think of a quite creative way that is going to be suiting for this landscape here. So there's quite high construction costs, and there's also quite a huge risk for the workers. You can sort of imagine working here is a huge risk, and so of course it's a quite difficult project to start. So high risk of danger to construction workers. So it's you cannot build infrastructure here. If you do, you have to use very expensive methods to build infrastructure here. So it's quite difficult because of the steep gradient here, as well as the hard rock, the cliffs there. It's very dry, and the rivers are too deep to practice farming. Imagine having to go down there by yourself to get water because these are very, very deep. But it's actually a good site for tourists. It's really beautiful. For an example, look at the Grand Canyon. The Grand Canyon is a perfect example of this. People come from all over the world and come to look at the beauty of this, the Grand Canyon in the US. So that is a good tourist attraction. So it's good for the economy. People come in, as I said, they spend money in your country, and so you benefit as a country there. So that is a canyon landscape, guys. It's not difficult at all. Okay, it's important that you understand the concepts of erosion. You understand the role of a river in eroding this landscape, in eroding land to form this landscape. So that is a canyon landscape. That's how it looks like. And the continuous erosion, more and more erosion, more and more erosion, and back wasting produces the Karoo landscape. So if you look at the Karoo landscape, guys, this was a canyon landscape at some point. Okay, so Karoo landscape formed from a canyon landscape, and it's due to back wasting or scarp retreat. It's basically whereby the slope erodes like that. Okay, it erodes. This material is removed, and so it basically moves to the back. Okay, we call that scarp retreat or back wasting. It moves to the back. It does not reduce in terms of the height, but in terms of the position, it moves back and back and back like this. So at some point, it will be like that. So basically, the width is affected and not the height. So it's such that you form these landforms here in the Karoo. So the Karoo landscape, it's a landscape where you're going to find flat-topped landforms such as mesas, buttes, and isolated hills or conical hills. These are the different types of landforms you're going to find in the Karoo. The Karoo is also a dry area. It develops from a canyon landscape, so you can sort of imagine. So a Karoo landscape simply was once a canyon landscape. But due to back wasting, as I said, back wasting, guys, as I said, this is simply that erosion of a landmass in such a way that the landforms become narrower and narrower, but not shorter. Okay, so you have, for an example, a landmass like that, and then back wasting occurs or scarp retreat occurs such that you have more material that is removed from the sides. Okay, so the width now, as you can see, becomes smaller and smaller and smaller. More and more material is removed in terms of the width. Removed. All of this material is removed, but now the height is still the same. So now you have this landform. It formed from the back wasting of a much wider landform. So with back wasting, you simply erode these slopes. You erode the slope in terms of the width. Okay, so it becomes narrower and narrower, but not shorter. So it's such that at some point it will look something like that, whereby the height is greater. Okay, the height of this landform, like that, the height is greater than the width. Okay, and yeah, that is a butte. So that is scarp retreat, guys. It's also called back wasting. It's also called parallel retreat. That's the concept of scarp retreat. Retreat is basically to move backwards, guys. My handwriting is so bad because I'm using a mouse. Yeah, so don't mind that. So that is parallel retreat, and it's caused by the lateral erosion. It's caused by mass movement. We'll talk about mass movement, and it's caused by weathering, constant weathering. So simply natural. It moves back, back, and back, and back, and back, as you can see. So at some point, it will be something like that at some point, because it moves, it is eroded such that it becomes narrower and narrower, but not the height. The height stays or remains the same. So this forms these Karoo land forms. Okay, you have a mesa. The mesa is simply a flat topped hill with a smaller height than the width. Okay, so as you can see, guys, the height is smaller than the width. The width is big. Okay, look at the width, it goes from over there or over there to there. So the width here is greater than the height. That is a mesa. Perfect example of this is your table mountain. Now, a mesa formed from a plateau. Okay, so you had a plateau at some point. So it's quite a plateau is quite wide, very wide, and due to back wasting, its width reduced, and eventually it formed this mesa. And if this mesa constantly undergoes back wasting, eventually it will become the next one, which is the butte. Okay, so back wasting of a mesa results in a butte. So a butte, this is a flat topped hill as well, but it has a height that is greater than the width. So take a look at the height here. This is, yeah, so that's what you look at, guys. Even if they give you, for an example, a photograph, okay, look at the height and compare it with the width. Which one is bigger than the other? And that's how you are able to identify a butte and a mesa. And then you also have a conical hill. Conical hill is the smallest one. And yeah, this is after the butte has undergone a lot of erosion such that the cap rock is even removed. So a conical hill is something that looks like that, a landform where the cap rock has been removed. That is the conical hill. Now, taking a look at these guys, you're going to find out that when I'm removing material here, removing material, this material will form this flat land here. Okay, they will accumulate there. Okay, so this flat land that is formed after the back wasting of a material, that flat land next to these landforms of the Karoo landforms, that flat land, we call that the paddy plain. It's a paddy plain. When you're back wasting, eroding, you will form the flat land that is next to these landforms. So this is an extensive flat surface of a Karoo landscape. So this flat land, for an example here, okay, the flat land that is in between these two, okay, that is a paddy plain. Now we're saying that Karoo, the Karoo landscape or the Karoo landforms, they develop out of canyon landscapes, and they love to ask how. How do Karoo landscapes develop out of canyon landscapes? So first things first, the mesa forms from a plateau that is eroded by the process of scarp retreat. Okay, so as I said, guys, for you to have a mesa, you have to have a plateau, and that plateau has to undergo that back wasting or scarp retreat, such that it becomes narrower and narrower, from being very wide to being a mesa, and the mesa constantly undergoes that back wasting to form a butte, and a butte, so on and so on, to form that hill. So back wasting or scarp retreat causes the cap to get narrower and narrower, and the base to get wider. This continuous back wasting erodes the mesa into a butte. So it's really important, critical. You cannot talk about Karoo developing out of canyon without mentioning back wasting, guys. It's important. You have to mention that. And then the impact that these have on human activities is that, well, these develop in arid areas. Okay, so as the canyon landscapes, and there's high soil erosion here, hence the soil is thin and is not conducive for farming or any human activities. But tourism, though, I should have added tourism there. People come for these types of landforms or types of landscapes, I mean. Right, so that is the differences, guys, between a Karoo and a canyon landscape. So take a look at the Karoo. Okay, it formed from back wasting of the canyon. That's how we got here from there. So that is a stark difference, guys. I hope you can see the difference there. Valleys here, there's no valleys in the Karoo. It's just flat land with a couple of landforms, your mesas, your buttes, your conical hills. That is Karoo. And then your canyon has a valley, stepped sides, deep river or deep valley. It has cliffs, it has those slopes, those gentle slopes on the sides due to the unequal resistance to erosion of those rocks there. Thank you for tuning in, and I'm hoping to see you in the next one.